Hello everyone, I'm Miss Chong. Today I'm going to show you how to measure the durations of a freeform motion using your smartphones and determine the acceleration due to gravity. Theory behind the experiment. When a body of mass m falls freely from a certain height h above the ground, it experiences a linear motion. The body will obey the equations of motions S equal to ut plus half at squared. The object is doing downward displacement from the falling point to the ground, so we have S is negative h. Initial velocity of the object is 0, so u is 0, and the object is fall freely in the air. It experiences a downward acceleration due to gravity, so a is equal to negative g. So we obtain h equal to half gt squared. So this is the relationship we are going to use for this experiment. We will measure the distance of fall h and the time t for different heights and use the data to determine the value of g. To measure the time, we are going to use the Acoustic stopwatch in Phyphox Apps. If you did not already install the Phyphox Apps, you can get it free on Android and iOS. Choose the Phyphox Apps. In the main menu, go for Timer and choose Acoustic stopwatch. When you start the blinking play button, it will simply count the time between two loud events. Threshold sets the volume at which it triggers. So if it is too sensitive and start because of background noise, increase the threshold. If you miss this event, decrease the value. So for our experiment purpose, we set the threshold as 0.04. Since any noise have a very short durations and reverberations can also be above the threshold, you can adjust the minimum delay to prevent a single sound event from triggering the stopwatch multiple times. If your sound event start and stop the stopwatch right away, you should increase the value. But this event should be always smaller than the time you're going to measure. For our purpose, we are going to set the value as 0.2. In this experiment, we are going to drop an object and measure the time it takes from its release until the impact on the floor. To do this, we need to do triggers to sound event which indicates the drop started and drop ends with the impact. With that, we can use the acoustic stopwatch to measure the time. The click pen being pressed initiate the drop of object would make a noise to start the stopwatch, and the impact on the floor makes second noise to stop the stopwatch again. So with a very simple setup, you can perform the experiment at home. The items you need for this home experiment are a smartphone with Phyphox Apps installed, an object you want to drop. For example, you might use a metal paper clip, marble, pendulum bob, or rock, a clipboard pen, measuring tape, masking or binding tape, or you might have blue tack. Let's set up the experiment and measure the time for freeform motion. Place the measuring tape along the edge of a vertical wall. Start with 0 cm at the floor. Hang the object at the tip of the click pen. Set falling distance hitch at 45 cm. Record hitch. Take out your phone. In Phyphox Apps, choose Acoustic stopwatch under Timer category. Set the value of threshold and minimum delay. Place the phone slightly away from the point of impact as the object hit the floor. Tap play to start the stopwatch. Press the clickball pen and let the object fall freely in air. Record the falling time T. Repeat the process to obtain average falling time. Press reset button to clear the reading. Reading for our second trial. Reset. Have our third trial. This is the reading for our third trial. Repeat the same step for different hitch. 55 cm, 65 cm, 75 cm, 85 cm, 95 cm. Tabulate your data. Remember to take a pictures of your complete setup and attach the picture in your practical report. Plot the graph of h against t squared. We should obtain a straight line. Boys and girls, so now we are going to plot the graph of h against t squared. First, we write down the title of the graph h against t squared. Then refer to the raw data we obtain. Choose an appropriate scale so that when you plot all the data, it would use at least 80% of the graph paper. Remember, the scale should be chosen in a way that the data are easy to plot and easy to read. Label each axis with the quantities and unit used. T squared, unit second squared. Y-axis, H, unit meter. Plot all the points clearly with cross. So, at these states, the distributions of graph points show that we would obtain a straight line graph. Calculate the centroid. Then we are going to plot it on the graph. Circle our centroid. Now we are going to draw the best straight line. Place a ruler on your graph. Adjust its positions. The best adjustment should be passed through the centroid and balanced. Points above the line are roughly in equal numbers and positions to those below the line. And remember, boys and girls, do not force the best straight line to pass through the origins of your graph, even though the presumed mathematically equations pass through 0, 0. So I repeat, Do not force the best straight line to pass through the origin of your graph. Remember, the best straight line should be pass through centroid and balance. Draw a line along the ruler edge that extends to the nearest coordinate axis at one end and somewhat beyond the last data point at the other end. Then we obtain the best straight line. Determine the gradient of the line by drawing a triangle. Triangle drawn should be large, more than half x-axis range. Read 2 points on the line correctly and determine the gradient of the graph. Then we are going to determine the acceleration due to gravity g from the gradient of the graph. Refer to equation h equal to half gt squared. Compare with the straight line equation y equal to mx plus c. Our x-axis will be t squared, y-axis is h. Thus, the gradient will represent half g. Rearrange the equations, we will obtain the acceleration due to gravity g is 2 times of gradient. Compare the acceleration due to gravity g obtained in experiment with the standard value. Under discussion, comment about the experimental value obtained. Is the value greater, equal, or less than standard value? State whether the experiment is success or not. If percentage difference calculated is less or equal to 10%, the experiment is considered success. State the precautions have been taken in the experiment. Identify the source of error, if any, and give suggestions to overcome the error. Write a full report for the experiment. Good luck when you do this experiment at home. If you have any further questions and issue on it, don't hesitate to contact your lecturer. Last but not least, don't forget to like and subscribe to Physics KMJ YouTube channel. Thank you for your focus and attention throughout the video. See you on next video. Thank you.